Hello, juniors. I hope you had a good winter break. Today, we're going to continue with our Logic and Statistics IB program. We're going to continue by working with probability tree diagrams, which is a concept that you already know something about. I think you worked with this last year. So, we're going to see this concept. We're going to review the concept of events with replacements and without replacement, and then we're gonna discuss a concept known as fair game. Okay, so the objectives for this class: number 1, use of Venn diagrams, tree diagrams, and sample space diagrams. Number 2, identify and calculate combined events, mutually exclusive events, and independent events. Number 3, define and apply conditional probability. And finally, find probabilities with and without replacement. Okay, so in order to review tree diagrams, we're going to be solving a series of exercises, and you'll see that this concept is quite easy. It usually does not present much trouble for students. Okay, so we're going to see the simplest form first, which is with replacement, also known as repeated events. It says, example, the probability that someone, a keen member of the school archery club, hits the bullseye is 0.8. Samuel takes 2 shots. Assume that success with each shot is independent from a previous shot. Independent means that the probability of the second shot does not vary depending on the result of the first shot, right? In a real life scenario, maybe this second shot may be altered. Its probability may be altered by the result of the first shot, right? But for this particular example, we're going to assume that they are completely independent events. Okay, so it says represent this information on a tree diagram. Find the probability that Samuel hits 2 bullseyes, 1 bullseye, and at least 1 bullseye. Okay, so first of all, we're going to draw the tree diagram. As you may have seen, in this particular case, we have 2 different possible outcomes, which is that Samuel either hits or misses the shot, right? And he has 2 shots. So our tree diagram will start with 2 branches, right? Because there are 2 alternatives. Either Samuel hits, I'm going to write it as an H, or Samuel misses the shot, M, right? So this would be the first shot he attempts. Then, after his first shot is done, he again has the second shot. So if he hits the first shot, for his second shot, he again has 2 possibilities, right? Let me see. The first possibility is that he hits again, and the possibility that he misses the second shot. Same thing, if he misses the first shot, he has 2 opportunities here. In one, he will hit, and in the other, he misses. Okay? So, let's write down the probability. It says that the probability that Samuel hits is 0.8, right? So, if this is 0.8, there's a property of the tree diagrams which says that the sum of the different branches should always be equal to 100%, right? Because we're contemplating all of the different possible events in the universe, right? So the sum of the branches is always equal to 100% or equal to 1, which represents 100%. That means that the probability of missing should be equal to 0.2, right? 0.8 plus 0.2 is equal to 1. Okay, so I forgot to write here, this is the second shot. Okay, so if the success of each shot is independent from the previous shot, then we know that if in the second shot, the probability of hitting again would be 0.8. So this is 0.8. This would also be 0.8. And if the probability of missing would be the same, right? 0.2, 0.2. You see that we're always fulfilling the property that the sum of the branches should be equal to 1. Okay, so with this information, we can already solve the problem. This is our tree diagram. So we're going to go to the questions. Question A says, find the probability that he hits 2 bullseyes. That is, probability of hit and hit. Okay, so if we look at our tree diagram, we see that there's only one possibility for that, which is 0.8 times 0.8. Remember, these are independent events, and that's why we're multiplying the probabilities. So if we multiply this, we're going to get 0.64. This would be the result for hitting 2 bull's eyes. Okay, part B. Hits only 1 bull's eye. Okay, so probability of, that would be 1 hit, right? 1H. So in this particular case, we have different possibilities, right? One possibility would be going hit first and then miss, and then the other possibility is missing first and then hitting, right? So there are 2 different paths. So there's one important thing here. Whenever we're going in one same branch, we multiply the probabilities, right? And whenever we jump to another branch, I told you this is one possibility, and then another different possibility in the universe would be this one over here, okay? So when we go from one possibility in the universe to another possibility in the universe, we add both probabilities, right? So we multiply whenever we go in the same branch, and we add whenever we jump to a different branch, basically, okay? So this would be, let me write this in words first. And this would be probability of hit, comma, hit and miss. And the other possibility in the universe is the probability of missing and then hitting, right? Pay attention that it says hits only 1 bull's eye. If it says hits 1 bull's eye, then I would have to contemplate a third possibility, which would be probability of hit and hit. But since it says only 1, then this possibility is not contemplated. Okay? So those are the 2 possibilities. Now I need to write the probabilities. In the first case, this would be 0.8 times probability of missing, which is 0.2, plus, and the other option in the universe is missing first times hitting in the second shot. Okay, so probability. So the probability of one hit would be equal to, this is, if we try to do without a calculator, this is 0.16 plus 0.16, and this is equal to 0.32. This is the probability of hitting 1 time, only 1 bullseye. Finally, for part C, it says hits at least 1 bullseye. Okay, I'm going to show you 2 ways in which you can find this part, right? There's a long way and then an easy way. The long way would be contemplating all the different options in the universe. So probability of at least 1 hit. If we look at our options in the tree diagram, we have hit, that is a possibility. We have then hit, miss, another possibility, and finally miss and hit. So there are 3 different possibilities, which if I write down would be a probability of hit and hit plus probability of hit and miss plus probability of miss and hit. Fortunately, we have already found all of this, right, in the previous items. So we could say that this is equal to hit and hit was 0.64, and the sum of these 2 was equal to 0.32 according to the previous item. So this is plus 0.32. If we add both of this, we're going to get the result. Let me duplicate this, which would be equal to 0.96, right? 0.96. So the probability of hitting at least 1 bullseye is almost 100%, right? It's 96%. Okay, so this would be the long way if you would have to calculate all of these terms. The short way, which I'm going to do it in a different color, I'm going to write, or we could also work it this way. Probability of at least one hit is equal to 1, which is 100%, minus the only option where I do not have one hit, which is miss, right? So 1 minus the probability of missing and missing. So this would be equal to 1 minus 0.2 times 0.2. This is equal to, if I do it here, 1 minus 0.04. So finally, the probability of at least one hit is 1 minus 0.04, which is again 0.96. Okay, so you see that this is a much shorter path, but you need to understand what you're doing in order to be able to do it this way. Okay, so that's another way of solving this. Okay, so I think this is clear. This is an easy topic, right? Now let's go to probabilities without replacement and conditional probability, it says. So, example, a bag contains 5 green balls and 6 red balls. If two balls are taken out successively without replacement, what is the probability that A, at least one green is chosen, and B, red is picked on the first pick, given that at least one green is chosen? Okay, so first of all, let's build our tree diagram, right? Although we're not asked to find the tree diagram, it's always good and convenient to draw the tree diagram to make the problem easier, right? So there are 2 alternatives in this universe, either picking green or red, right? So there are going to be 2 branches in our tree diagram. The first one is if we pick green, and the other option in the universe is picking red, right? What would be the probability of picking green? We have 11 balls in total. 5 of them are green. So it's 5 out of 11. And the probability of red is 6 out of 11. You see that the addition of both, 5 over 11 plus 6 over 11 is 11 over 11, which is 100% of the universe. Because it's 1, right? So if we pick green, then again, we have 2 different options in the universe. We can again pick green, or we could pick red, right? But here's where something changes, right? If this is without replacement, and I already took 1 green, that means that I have 1 green less in my universe. So instead of having 5 green balls, I only have 4. And in my universe, I do not have 11 balls anymore. I have 10, right? So that's the new probability for green. And the new probability for red would be, since I haven't taken any red ones yet, I still have 6, but my universe is now 10 because I took 1 ball without considering the color, right? I took 1 ball from the back. And same thing if I work with red, right? 2 options in the universe, picking green or picking red. If I took first red and then took green, then this would be 5 out of 10. And if I pick red and then red again, this would be 5 out of 10. 5 out of 10 as well. So you see that in both cases, the addition of this would give us 10 out of 10, which is 100%. And this plus this is also 10 out of 10, which is 100%. So that means that we're doing this correctly. Okay, once I have my tree diagram done, let's call this is the first pick. This would be the second pick. Okay, so now that we have done this, we can work with the exercise. For part A, it says, find the probability that at least 1 green is chosen. At least 1 green, again, we can do the long way or the short way, right? The long way would be identify all of the events which have at least 1 green, right? This path, for example, or this path, for example, or this path over here. So we have 3 different alternatives for at least 1 green. Or if we want to do it the short way, we could just say it's 1 minus, like 100% minus the only alternative in which I do not pick any green, which is red, red, okay? So I'm going to do that short way because I want you to be able to easily identify when this is applicable. So probability of at least one green would be equal to 1 minus the probability of picking red and red, right? So this is 1 minus probability of red and red would be 6 out of 11 is the probability of picking the first red times 5 out of 10, which is the probability of picking the second red, because we're talking about probabilities without replacement, right? So then we need to solve this. Let me duplicate this. So if we solve this, we're going to say this is equal to 1 minus 6 times 5, that's 30, and 11 times 10, that's 110. 110. So if we simplify, here you can see 1, 0 simplifies. So this is equal to 1 minus 3 over 11. If we want to subtract this, we could say that this is the same as 1 is the same as saying 11 over 11 minus 3 over 11. And then we can easily subtract 11 minus 3, that is equal to 8, right? So probability of at least one green would be 8 out of 11, okay? I hope this is being clear for you guys. Okay, just give me 1 second. Okay, let's move on to part B. Part B, which says the following. Find the probability that red is picked on the first pick, given that at least one green is chosen. Okay, so we have the famous given that. Whenever we have given that, you should recognize that we're talking about conditional probability, right? So red is picked on the first pick, given that at least one green, right? So I'm going to write this as probability of first pick is red, given that, remember, the symbol for given that is a vertical line, right? Given that at least one green. At least one green. Okay, so if you remember from the formula for conditional probability, let me show you the formula just a second. Here we have the formula booklet. If we go to topic statistics, topic 4. If we go to probability, right here, you see that conditional probability has this formula. Conditional probability A given that B is A and B over probability of B. Okay, so we're going to apply that same formula to our problem here. So this should be probability of red and green, given that we have at least one green. At least one green. One green. That is the formula for conditional probability. Okay, so if we fill in these values, we know that the probability of picking red and green is this path over here, red and then green, right? Remember, red should be our first choice. So this is 6 out of 11 over 5 over 10. 6 over 11 times 5 over 10. And this is being divided by the probability of at least one green, which we already found in the previous exercise, which is 8 out of 11. Okay, so then we need to solve this fraction. I see that the 11 simplifies here. And then, okay, you need to remember how to work with fractions, right? We can, in this case, multiply. whenever we have fraction over a fraction, it's always the top part with the bottom part, and then the middle part you multiply together, right? So basically what we need to do here is, let me write this down here. I'm going to duplicate. And we're going to say that this is equal to 6 times 5, that's 30. And 8 times 10, that's 80. If we simplify the 0, we're going to get the probability, which would be equal to 3 out of 8. So that's the probability of picking first red, given that I have at least one green. Okay? So that's basically an exercise with tree diagrams without replacement. Okay? Let's see one last example about tree diagrams. It says, Toby is a rising star of the school tennis club. He has found that when he gets his first serve in, the probability that he wins that point is 0.75. When he uses his second serve, there is a 0.45 chance of him winning the point. He is successful at getting his first serve in 3 out of 5 occasions, and his second serve in 3 out of 4 occasions. Find the probability that the next time it is Toby's turn to serve, he wins the point. And B, given that Toby wins the point, what is the probability that he got his first serve in? Okay, so once again, we're going to have to do our tree diagram. Again, we only have 2 branches, right? Because in this case, we're talking about hitting or missing the serves, right? And we're going to have the tree diagram will have 2 parts, because one corresponds to the first serve and the second part corresponds to the second serve. So let's start doing the tree diagram. For the first serve, we have 2 options, right? Either we hit the first serve in, or we miss, right, our first serve. So miss here. So I'm going to write here that this corresponds to the first serve. There. Okay, if we hit the first serve, then we have 2 options. Either we win the point or we lose the point, right? So you need to pay attention to what we're talking about in the problem, okay? So we win the point or we lose the point. Now, if we miss, we have our second serve, right? Anyone who plays tennis should know that these are the rules, right? If we miss, we have the opportunity of taking a second serve, which we could either, again, hit or miss, right? Or miss. If we miss, we lose the point, right? But if we hit, we have 2 options again. We can either win the point or we can lose the point. So this will be the complete tree diagram for this particular case. Okay? So now that we have, so this is the second serve here. So now we need to analyze the probabilities, right? Here it says he has found that when he gets his first serve in, the probability that he wins the point is 0.75. Okay, so if he gets his first serve in, winning is 0.75. That means that losing should be 1 minus 0.75, which is 0.25. Okay, then it says, when he uses his second serve, there is a 0.45 chance of him winning that point. So if he uses his second serve, he hits the second serve, the probability of winning decreases to 0.45. That means that the probability of losing would be 0.55. He's more likely to lose if he uses his second serve. Okay, then it says he is successful at getting his first serve in 3 out of 5 occasions. So hitting the first serve has a probability of 3 out of 5. That means that missing the first serve would be 2 out of 5, right? And then it says, and his second serve on 3 out of 4 occasions. So hit in 3 out of 4. 3 out of 4. That means that the probability of missing the second serve is only 1/4. Okay? Super. So now that we have built our complete tree diagram, solving the exercise itself should be easier, right? It says, find the probability that the next time it is Toby's turn to serve, he wins the point. So basically what we want to calculate is the probability of winning the point, right? So what we're going to calculate is the probability of win. To calculate probability of winning, we need to analyze all the different possibilities in the universe. One is this path over here, and the other would be this path over here. All of this, right? Here we have three different probabilities that we need to multiply, right? So if we write this down, we're going to say that it's 3 over 5 times 0.75. Since we're jumping to another branch, it's plus 2/5 times 3/4 times 3/4 times 0.45. Okay, so once we have done all of this, we need to solve for this. In this case, it's easier if we do it with a calculator. So the probability of win would be equal to, this is 0.585. Okay, that's the probability of winning. Super. Then we have part B, the last part, which says, given that Toby wins the point, what is the probability that he got his first serve in? So given that, again, we're talking about conditional probability, right? So the probability of a first serve in, given that he wins the point. That's what we're being asked. So the given that part would be our denominator, right? So in the denominator, we're going to have probability of win. And in the numerator, we're going to have the only path in which he gets the first serve in and wins, right? Which is this part over here. So I'm going to write this as probability of hit and win, basically. So if we fill in this with values, we're going to get that this is 3 out of 5 times 0.75. And all of this is being divided by the probability of winning, which we found in the previous item, which is 0.585. 585. Okay, so if we solve this, we can use calculators because we get some ugly numbers. This would be equal to 0. Just a second. This would be equal to 0.769. That's the probability of winning the point given that, of getting the first serve in given that he wins the point. Okay? There's one last thing here, but I'll discuss this with you in our virtual class tomorrow, okay? So I hope this was clear enough for you, juniors. If not, please let me know. We're gonna see some exercises later on about this. So that'll be it for today's class. See you.